Hey everyone, welcome to Joey's Tech. I am Joey, your friend, and in this video you will learn to find ugly numbers using dynamic programming. At this moment I'm so excited because I'm sure that you are going to enjoy learning about ugly numbers and finding them at a particular position if you are a math buff or an algo lover. But if you're not, then this problem could attract you towards math as well as algorithms. So stay tuned to this video and I'll tell you to find ugly numbers in the most efficient way. Not only that, but I'll tell you how to think of the approach to solving the problem. Before we proceed to the problem, just hit the subscribe button for me if you're new to this channel, because that encourages me enormously to make such videos for you. Do not forget to hit the bell icon because that way you get notified whenever I release videos in future. So now let's move to the problem. Ugly numbers. Ugly numbers are those numbers whose prime factors are 2, 3 or 5. This is the main definition of ugly numbers. Okay, if a number has to be classified as an ugly number, then the prime number factors of that particular number has to be either 2, 3 or 5 or all of them. All right. Okay. So 21 cannot be an ugly number even though we have 3 as its prime factor, because it also has 7 as its prime factor. Hence it cannot qualify as an ugly number. 14 cannot be an ugly number because even though 2 is one of the prime factors, but 7 is also one of its prime factors. Hence it cannot qualify as an ugly number. Okay, so please keep that in mind. 1 is considered as the first ugly number. Now this is a well-known fact that 1 is considered as the first ugly number in the ugly number series. Now I'm listing down the first 11 ugly numbers here for you. So 1, 2, 3, 4, 5, 6, 8, 9, 10, 12 and 15 are the first 11 ugly numbers in the series. Okay, it's an ugly number series, just like we have a Fibonacci series. It's an ugly number series, and as you can see, if you have 4, which is the third ugly number, then you will find that find 2 as one of its prime factors. As if you are considering 6, then you are going to find both 3 and 2 as its prime number factors. So this is how these ugly numbers are formed, and you have to keep in mind the basic foundation, the basic concept behind ugly numbers. Our job in this problem is to find nth ugly number using dynamic programming technique. So in this particular series, if you look into, then if I tell you to find out for me what is the third ugly number, then you are going to obviously say 3. Okay, the 7th ugly number, it is obviously going to come as 8. Okay, so this is the problem when the series is going to get bigger, and if I ask you how to find 150th ugly number, then you cannot do all these calculations. There has to be an algorithm which in the most optimized way or an efficient way finds the 150th ugly number for us. So this is what we are going to solve using this ugly numbers problem, and this algorithm we are going to create using dynamic programming. So now let's move to the framework where we are going to solve our problem of ugly numbers. Alright, so here we are at our framework where we will solve the ugly numbers problem using dynamic programming. Now before we proceed to solving the problem, actually, like I told you that I'll tell you how to find the approach, how to approach towards the solution of this problem. I want you to think with me what can be the components which are going to form the solution of the problem. Alright, so it's like when we have thought of the components, we are going to put the dots in the canvas, and connecting those dots is going to be really easy for us. All right. At this point of time, I can think that one of the components can be the series of each of the individual prime integers. So the definition states that an ugly number is formed of 2, 3 or 5 or all of them. Okay, so if I put 2 over here, 3 over here and 5 over here, all right, and if I create the series of each of these individual integers, they all are going to be ugly numbers, aren't they? So if I multiply 2 by 1, I will get 2. If I multiply it by 2, I'll get 4, then 6, then 8, then 10. Now all these are ugly numbers which are coming out of the series of prime number 2. Similarly for 3, let me form the series 9, 12 and 15. So these all are ugly numbers which are coming out of the prime integer 3. Similarly for 5, 10, 15, 20, 25. Alright, so all of these are ugly numbers, okay, and they are coming out of the series of individual prime numbers with which the ugly numbers are made of. Now we have this array. Since we are talking about dynamic programming, hence storing the optimized solution of the subproblems is a key. So obviously it is very much obvious that we will store the optimized solution of each of the subproblems in this array. Alright, so we have to correlate these series over here with this array, and these two are the components, okay, which are going to form the solution of our problem. Now we cannot keep the series like this, but we can surely think that this series is being formed by multiplying 2 with numbers which are incrementing. Hence, those numbers can be the numbers of an index. Hence, I will form 3 indexes over here. Index 2, index 3 and index of 5. Alright, I am going to omit this because this was for the sake of example and for picturizing our thinking. Alright, now like I told you, there has to be a correlation between these indexes and this integer. Hence, I'm sure that these indexes must begin from 0. Okay? When you have solved enough dynamic problems, these things would automatically occur to you. So don't worry, just keep practicing. But at least the approach to solving the problem is becoming clear now. Alright, now if we multiply the number which is at this index, what values we are going to get? So we multiply 2 with the value at index 0, which is 1. So I get 2, then I get 3, then I get 5. Cool. And we are going to denote them using a different variable, which is going to be next multiple of 2. Okay, so I have made a mistake over here. All right. So we are denoting these 3 numbers using different variables over here, and those variables are next multiple of 2, next multiple of 3 and next multiple of 5. So we have our first ugly numbers over here. We have our candidates of the first ugly numbers over here. Now we are battling for this position, what an ugly number would be at this spot. Okay, now logically you know that after 1, 2 is going to be the ugly number. So we are getting 2 over here, but how we are going to pick it every time? It's simple. We are going to find the minimum value out of these 3 integers. So minimum value, I'm going to put 2 over here. Now this also means that we have taken one value from the series of integers which are coming out of the prime number 2. Okay, just like I showed you the series. Hence, it's our time that we increment this index by 1, because one number has already been taken from our series. Hence, it's time that our counter moves to the second number in the series. That is why I will increment this index by 1. But these indexes will be untouched because no numbers have been taken from the series of 3 or 5. Okay, it will be more clear to you as we proceed. Now let's move to this number. So I am trying to find the ugly number for this spot. So I will multiply 2 with the value which is at index 1. So it is 2. So 2 into 2 is going to give me 4. Let me bring these numbers in the middle as well. Alright. Now 3 multiplied by value at index 0. So it is going to give me 3. And 5 is going to stay as 5 because 5 into the value at index 0 is 1. 5 into 1 is 5. Now let's find out the minimum value out of these 3 integers. That value is coming as 3. So I'll put 3 here. So this is the ugly number. 3 is the ugly number at spot 2. Again, the same concept applies. We have taken this ugly number from the series of 3. Hence, we will increment the index, this index of 3 by 1. That means one number has been taken from the series of 3. Now the counter moves to the next number. Alright, and these numbers which we are storing here are the optimized solution of the subproblems. That means at index 2, that means if I ask you to find me the third ugly number, then it is going to come as 3. Alright, everything is happening according to the concept. So let's quickly fill this array using this concept that we have discovered. Okay, this approach that we have discovered here. Alright, so 2 multiplied by value at index 1, which is 2. So it is going to stay as 4. 2 into 2 is 4. 3 multiplied by value at index 1, which is 2. So 3 into 2 is going to be 6. Cool. 5 multiplied by value at index 0, which is 1. So it is going to stay as 5. We find the minimum value. This is 4. I put 4 over here and this value gets incremented by 1 because 4 has been taken from the series of number 2. Alright, 2 multiplied by value at index 2, which is 3, so this becomes 6. Okay, then 3 multiplied by value at index 1, which is 2, so this stays at 6 and this stays as 5. Minimum value out of these 3 is 5. I put 5 over here and we have our account open in the series of 5. So this will be incremented by 1. Okay, so cool. Alright, now we find the ugly number for this part. 2 multiplied by value at index 2, which is 3, so it stays as 6. 3 multiplied by value at index 1, so which is 2. 3 into 2, 6, stays 6. Then 5 multiplied by value at index 1, which is 2. So 5 into 2 is going to be 10 over here. The minimum value out of these 3 is 6. So I'll put 6 over here. Now we have joint winners over here. Okay, that means 6 has been taken from series of prime number 2 and 6 has also been taken from the series of prime number 3. Alright, hence we are going to increment both the indexes by 1. So this will become 3 and this will become 2. Okay, we are going very fine right now. Now we have to find the ugly number for this part. Alright, So 2 multiplied by value at index 3, which is 4, so this becomes 8. 2 multiplied by value at index 2, 3 multiplied by value at index 2, which is 3, so 3 into 3 is 9. And 5 multiplied by value at index 1, which is 2, so this is 10. 8 is the minimum value. I get 8 over here. This again gets incremented by 1. Okay, 2 into 2 multiplied by value at index 4, which is 5, so I get 10 over here. 3 multiplied by value at index 2, so I get 9, which is already there, and 10 is already going to be there because 5 is going to be multiplied again with 2, alright, which is the value at index 1. So I get 9 as the minimum value. I put 9 over here, I increment this value by 1. Cool. So 2 multiplied by value at index 4, which is 5, I get 10. 3 multiplied by value at index 3, which is 4, so 3 into 4 is 12. 5 multiplied by value at index 1, which is 2, 5 multiplied by 2 is 10, so this is going to stay 10, but the minimum value I am going to get is 10, and since 2 and 5 both have this minimum value, hence we again have joint winners, and that is why this index gets incremented to 5 and this index gets incremented to 2. Cool. Alright. Now 2 multiplied by value at index 5, it is 6, so this becomes 12. 3 multiplied by value at index 3, which is 4, so this is going to stay as 12. 2 multiplied by value at index 2, which is 5 multiplied by value at index 2, which is 3. So 5 into 3 is going to come out as 15. So minimum value is 12. We again have joint winners. So this is going to be 6. This is going to be 4. And this is going to stay as 2. Now the final spot, because we need the ugly number for the 11th spot. Okay, that is the demand for this problem. Okay, I might not have told you that, but I created an array of 11 spots, 11 cells, hence it is obvious, it is evident that I am seeking to find the ugly number for the 11th spot or the 11th ugly number. Okay, so we have reached to the final iteration of our solution. Alright, so 2 multiplied by value at index 6, it's 8, so 2 into 8 is 16. 3 multiplied by value at index 4, so it is 5, we are going to get 15 over here, and 5 multiplied by value at index 2, so it is 3, so we are again going to get 15. 15 is the minimum value. I populate 15 over here, and since we have joint winners again, so this index becomes 5, this index becomes 3, and we have got the ugly number at 11th position, and that is what we were seeking, okay, as a part of this problem, as the solution of this problem. So we have our winner over here, number 15. Alright, now let's move to finding the algorithm of our solution. So here is the algorithm of our solution. Ugly number equals to minimum of next multiple of 2, next multiple of 3, and next multiple of 5. I'm sure that it is very clear to you by now. The time complexity of this dynamic programming solution of the ugly numbers problem is O within braces n. If you had adopted any other approach, any other naive approach, the time complexity would have become O within braces m into n. So with this, we have come to the end of this video. I'm sure you have liked this video. If you have liked this video, please hit the like button. I'll see you in the next video of Joey's Tech. Thanks for watching this video. Goodbye.